Welcome to Chemistry for 10+2. Dear students, today we are going to understand the nomenclature in alcohols, phenols and ethers. So let's begin with it. Dear students, now we are going to understand nomenclature in alcohols. There are three systems of nomenclature of monohydric alcohols. The first system is common or trivial system. The common names or trivial names of alcohols are obtained by adding word alcohol after the name of alkyl group bonded to OH, that is alcohol or hydroxyl group. Names of higher alkyl groups also include prefixes like normal, iso, secondary or tertiary. To understand this, let's have the examples. As we know, name of alkyl group is to be followed by alcohol. Commonly, we can write it as alkyl alcohols. Let's see the example. CH3OH. In this, the alkyl group attached is methyl group bonded to OH group. So, in common name system, to name the alcohol, first we have to write down the alkyl group followed by OH, that is indicating alcohol. So, here the name of this alcohol is methyl alcohol. So, CH3, which is denoted by methyl group, and OH, for which we are going to write down alcohols. Let's see another example. In this case, we find there is the alkyl group, that is propyl, to which OH group is attached. So first we have to write down the name of this alkyl group, and it is to be followed by alcohol. So the name of the compound is N-propyl alcohol. Let's see another example. You can try of your own. Here, this compound contains 4 carbon atoms, CH3, CH2 3 times and OH. So, the name of the compound is N-butyl alcohol. Names of higher alkyl groups also includes prefixes like normal, iso, secondary and tertiary. Let's see the example to understand it well. As it can be seen here, let's try with this example. CH3, CH2, CH2OH. Here, the name of the common name of this compound is N-propyl alcohol. Here we find the group, that is alkyl group, which is attached is N-propyl group. And OH, we have to indicate it by following it with alcohol. Let's talk about secondary butyl alcohol. Here, in this case, we find CH3, CH2, CH bonded to CH3 and OH. OH group is attached to secondary carbon atom. And the alkyl group which is attached here is secondary butyl group. That's why it is said to be secondary butyl alcohol. Since OH group is attached to secondary carbon atom of the butyl group, it is said to be secondary butyl alcohol. Let's understand another example. In this third case, we find OH group is attached to CH2 group. This is the part of a butyl group, which is isobutyl group, as it has branching. So, when we have to write the common name of this compound, the alkyl group which is attached here is isobutyl. Since OH group is attached to CH2 group, we have to follow it by writing alcohol. Let's talk about secondary butyl alcohol. Here, in this case, OH group is attached to tertiary carbon atom of the alkyl group which contains 4 carbon atoms. Since it contains 4 carbon atoms, it is the derivative of butane. And OH group being attached to tertiary carbon atom, it is said to be tertiary butyl, and since OH group is attached, it is to be followed by writing alcohol. So in this way, few examples we have seen to understand how to write common names of alcohols in such a way. The second system of nomenclature of alcohols is carbonyl system. In this system, alcohols are derivatives of methyl alcohol, which is called carbonyl. Alkyl group attached to the carbon carrying OH groups are named in alphabetical order and suffix carbonyl is added. Let's understand it with example. As we can see here, CH3, CH2, OH. Here we find the OH group which is attached to the carbon atom is said to be carbonyl carbon. And the name of the compound is methyl carbonyl. Let's take another example. CH3, CH2, CH2OH. Here, this is the carbonyl carbon. The name of the compound is ethyl carbonyl. The third system of nomenclature of alcohols is IUPAC system, International Union of Pure and Applied Chemistry. Let's begin one by one, stepwise, and understand the nomenclature of alcohols by this system. First one, alcohols are named as alkenols, replacing E of alkanes by suffix OL. Let's understand it with example. Here we find CH3OH. The name of the compound in IUPAC system is methanol. Here we find, since this compound contains one carbon atom, it is the derivative of methane. As this compound contains OH group, E of methane is to be replaced by OL. As we can find here, alcohols are named as alkenols, replacing E of alkanes by suffix OL. So E of methane is removed and it is replaced by suffix OL. Let's see another example. CH3, CH2, CH2OH. The name of the compound is propanol. In this compound, there are 3 carbon atoms. So it is the derivative of propane. E of propane is removed and it is replaced by OL as we find OH group is attached to this carbon chain. That's why in IUPAC system, the name of the compound is propanol. Let's have one more example. CH3, CH2 3 times, OH. In this compound, it contains 4 carbon atoms. So it is the derivative of butane. And OH group is also present. Name of the compound is N-butanol. E of butane is removed and replaced by the suffix OL. Now let's understand the second point. Longest chain of the carbon atoms bearing OH group is selected. Let's understand it with example. CH3, CH2, CH2OH. Here we find that it is numbered 1, 2, 3. We have selected the longest chain and we have numbered in this way. But this is not the correct way of numbering. Then how should we write the numbers, or how should we number the carbon atoms? This is the correct way of numbering. Why this is correct? Let's understand. The OH group which is closest to that carbon atom, from that side we have to start numbering. If we number this carbon atom as first one, the OH group will be seen attached or bonded to third carbon atom. That's why this is the wrong way of numbering. We should number the carbon atoms in this way and start from that side where OH group is attached to the first carbon atom, as it can be seen here. Third point is numbering of carbon atom is done from that end which is nearest to hydroxyl group. So as you can see here, hydroxyl group is closest from this carbon atom and not from this carbon atom. So this is the correct way of numbering. Let's take another example. CH3, CH2, CH, CH3, and to this CH, to this carbon atom, you will find OH group is attached. Now let's understand how to number the carbon atoms. It is seen 1, 2, 3 and 4 in this case. But here we find this is not the correct way of numbering. We have to number it in this way. Why it is so? Because numbering of carbon atom is done from that end which is nearest to hydroxyl group. So this end is close to hydroxyl group, so we have to start numbering from this end, as it can be seen here. Let's talk about the fourth point. Position of other branches are indicated by proper numbers. Let's understand it with example. CH3, CH2, CH, CH2OH, and to this carbon atom we find one CH3 substituent is attached. Here we have to number this as carbon atom number 1 as it is closest to hydroxyl group. So the name of the compound is, we find it is 2-methyl-butanol. The longest chain contains 4 carbon atoms. So it is the derivative of butane. E of butane is to be removed and it is to be replaced by OL. So it is butanol. To the second carbon atom, we find the substituent attached is methyl group. So we have to write down the position, that is 2, because to the second carbon atom methyl group is attached. So 2-methyl butanol. The name of the compound is 2-methyl butanol. Now here it is not to be named in this way because we have to write down the position of OH group. Position of other branches are indicated by proper numbers. And secondly, locant indicating position of hydroxyl group is entered immediately before the suffix OL. So here, to write down the complete correct name of the alcohol, we have to write it as 2-methyl butan 1-ol. Because OH group is attached to first carbon atom, so we have to write down and indicate the position or the locant of hydroxyl group immediately before the suffix OL. Thus, this is the correct way of naming alcohol, 2-methyl butan 1-ol. Substituents are arranged in alphabetical order. Let's understand it with example. As we are knowing, first we have to select the longest chain and we have to number it. So here 1, 2, 3, 4 and 5 because this contains C2H5 indicates that there are 2 carbon atoms. And to the third position we find a group attached is C2H5, and to position 2 we find another group attached is CH3. So the name of the compound can be written as 3-ethyl 2-methyl pentan 1-ol. Now the longest chain contains 5 carbon atoms. So it is the derivative of pentane. E of pentane is removed and replaced by OL. Since OH group is attached to first carbon atom, we have to indicate here the locant. So pentan 1-ol. Now in the longest chain we find 2 substituents are attached. One is methyl group which is attached at position 2 or second carbon atom, and to the third carbon atom ethyl group is attached. Here when we are writing the name of the substituents, they should be written alphabetically. That's why the name of the alcohol here is 3-ethyl 2-methyl pentan 1-ol. This is how we can write the name of alcohol. Let's understand the 7th point. While naming polyhydric alcohols, the suffix E of the parent alkane is retained. Prefixes like di, tri, tetra are added before suffix OL, and position of OH group are indicated by appropriate locant. Let's understand it with example. Here it is. First we have to select the longest chain. Here the longest chain is C2H5, CH, 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 CH2OH. Here 3 OH groups are present and 2 substituents, that is 2 alkyl groups, are attached. We have to start numbering from this side, as from this side we find the OH group is closest. So this will be our carbon atom number 1, 2, 3, 4, 5, 6 and 7. Since it contains 7 carbon atoms, it is the derivative of heptane. Now here in this chain, in this longest chain, this carbon atom is 4th one, to which a substituent CH3 is attached. To the 5th carbon atom, one more substituent, that is methyl group, is attached. To the first, 2nd and 3rd carbon atoms, OH groups are attached to each. Therefore, the name of the compound is found to be 4,5-dimethyl. To the 4th carbon atom and 5th carbon atom, 2 methyl groups are attached. So it is indicated by di. Di indicating 2. So dimethyl heptane 1, 2, 3 triol. Now here we need not have to replace E. It is to be left as it is. So when we are having polyhydric alcohols, this E is to be left as it is. It is to be retained in the name of the alkene. That's why the correct name of this alcohol is 4,5-dimethyl heptane 1, 2, 3 triol. So at position number 1 there is OH group, at 2 there is OH group, as well as to the 3rd carbon atom also there is OH group. Tri indicating 3 and OL indicating that it is an alcohol. So 4,5-dimethyl heptane 1, 2, 3 triol. Now let's understand the next point. Cyclic alcohols are named using the prefix cyclo and considering the OH group attached to first carbon atom. As we can see here, this is a cyclic ring. To this cyclic ring, OH group is attached. The carbon atom to which OH group is attached is considered as carbon atom number 1. Since the ring is cyclic and it contains 6 carbon atoms, the name of the compound is cyclohexanol. Cyclo indicating cyclic. Cycle contains 6 carbon atoms, so it is the derivative of hexane. That's why cyclohexanol. OH group is attached, which is shown by OL. So cyclohexanol. In this compound, we find the cyclic compound this carbon cycle contains 5 carbon atoms, in which OH group is found and a substituent methyl group is found. The carbon atom to which OH group is attached is considered as carbon atom number 1. And the alkyl group is attached to carbon atom number 2. We have to find out the closest way, and not this way we have to move. We have to go in this way so that it will be closest to OH group. So the name of the compound is 2-methyl-cyclopentanol. 2-methyl-cyclopentanol. Here are few examples you can study of your own. Write down the structural formulas and try to find out their common names and IUPAC names of your own. Let's talk about the nomenclature of phenols. What are phenols? Phenols are hydroxyl derivative of benzene, or they are said to be the phenols are nothing but, we can say, this the IUPAC name of benzenol. Here we find the common name of phenol is accepted by IUPAC. The common names have prefixes like ortho, meta and para in substituted phenols. Let's understand it here as here. Phenols, ortho, that means 1,2 disubstituted. 1,2 disubstituted phenols are indicated by ortho in common name system. 1,3 disubstituted phenols are indicated by the word meta, whereas 1,4 disubstituted benzene is indicated by para. Examples for ortho, or you can say 1,2 disubstituted benzene ring, we find here this is 1,2 disubstituted. The position which is having OH group, or the carbon atom which is attached to OH group directly, is considered as carbon atom number 1. So the name of the compound is orthocresol, or we can say 2-methyl-phenol. Here, if OH group is attached to this carbon atom, it is carbon atom number 1. This will be 2, this will be 3. The name of the compound is metacresol. It is the common name, and IUPAC name is 3-methyl-phenol. In third case, we find if here it is OH group, then this carbon atom will be carbon atom number 1. Automatically, this will be carbon atom number 4. From any side, it will be carbon atom number 4. So here, the name of the compound is paracresol, and IUPAC name is 4-methyl-phenol. Let's talk about phenols containing 2 OH groups. Dihydroxy derivatives of benzene are known as 1,2, 1,3 and 1,4 benzene diol. Let's understand it with example in detail. As we can see here, this compound contains 2 OH groups. The name of the compound is benzene 1,2-diol or catechol. This compound also contains 2 OH groups. The position is 1,3 position. Here it is 1,2 position. The name of the compound is resorcinol. IUPAC name is benzene 1,3-diol. This is 1,3 position. So benzene 1,3-diol. Third compound containing 2 OH groups. The name of the compound is hydroquinone or quinol. IUPAC name is benzene 1,4-diol. Let's talk about nomenclature of phenols. which contain 3 OH groups. These are trihydroxy derivatives of benzene, which are known as 1,3,5, 1,2,3 and 1,2,4 benzene triol. Let's understand it with example. In this example, we find there are 3 OH groups. The name of the compound is fluoroglucinol. IUPAC name is benzene 1,3,5-triol. Let's see another example. The name of the compound is pyrogalol. IUPAC name is benzene 1,2,3-triol. Let's see one more example containing 3 OH groups. The IUPAC name of this compound is benzene 1,2,4-triol. Here are few structural formulas shown in this chart. You can write down the common names and IUPAC names of your own. Practice it so that you will have strong command on the nomenclature of phenols. Another chart is there which is showing the structural formulas, their common names and IUPAC names which we already have studied. Try to write it of your own. Now we are going to see the nomenclature of ethers. General structure of an ether is ROR. Here, the 2 alkyl groups attached can be same or can be different. If they are different, they can be indicated by as R1 and R2. How do we know that the compound is an ether? Here is the example. There is centrally placed oxygen atom which is divalent, and to this divalent oxygen atoms maybe 2 alkyl groups are attached, or 1 alkyl, 1 aryl, or maybe both aryl groups are attached. Such compounds are said to be ethers. The general formula, we have got 2 groups R1 and R2, and they are separated by divalent oxygen atom, as I have told you. These 2 groups R1 and R2 are alkyl or aryl groups. For example, here we can see this is dimethyl ether. There are 2 systems by which we can name ethers: common name system and IUPAC system. Let's talk about the naming of ethers by common name system. Ethers have 2 alkyl or aryl groups attached to the divalent oxygen. Therefore, the common practice is to write the 2 alkyl or aryl groups in the alphabetical order, followed by the word ether at the end. In case of ethers, the same alkyl or aryl groups on either side of oxygen atom, the prefix di is attached before the name of the alkyl group. Let's talk about the IUPAC name system of naming ethers. In this system, Ethers are named as alkoxyalkanes. One of the group is used as an alkoxy group and other as the parent alkane. Larger group forms the part of parent chain while lower alkyl group constitutes the alkoxy group. Let's study some examples of ethers.